Alright, so I found another approximation to the perimeter of an ellipse using binomial GIC. It actually turns out to be a really, really simple, pretty equation. It's not, it doesn't, like, this is the so this is kind of the standard basic approximation. I have, this should be a squared, but what I have is everything set to a being 1. A is unity, so that you can compare everything without having to invoke eccentricity. Right, so the only thing that changes is b, and b is a fraction of a. Okay. It could be all of a, in which case we have the circle, and you're just looking at 2 pi is your value. So this is the standard simple version of this, which is pretty good out to maybe around this area, and then it just gets pretty bad because it should be landing here. That's where it should end up. So here is my previous approximation, which uses transcendental functions, and like this is not that nice, but it only uses eccentricity. That's its only input is eccentricity, so that's kind of nice. Now the one that I got today, actually I have it written here 2 different ways. So this is the more expanded form. Wait, actually this one is, yeah, okay. Well, you can see what curve it draws. It draws this nice curve up here. Up here you can see that everybody agrees pretty well. Everybody agrees pretty well. This red dotted line, this one, it's actually slightly too large up here. For the most part, both of these are closer to the correct value in this territory, and then at right about a half is where it, really close to a half, is where they start diverging in the other direction. But this new one specifically carries on, comes really close to the right value. It doesn't actually hit 2 right here. It goes slightly below. So there is error here. There's pretty bad error right in this territory right there. But it is way better than this guy, which is, and it's about as complicated to handle as this. Right, given that this is comparable in complexity to this, it's far simpler than Ramanujan's approximations, and the error is far less than this. Especially out here, out in this territory. It's about the same over here, really close. You can see the error starts getting pretty bad over here. Yeah. But given that it's such a simple way to look at it, it's really, really nice. It's fully constructible. There's no transcendental functions. There's no like weird roots. It only involves squares and square roots, right? So here, given eccentricity, since this is mapped 0 to 1 eccentricity so that this works, I found b with respect to eccentricity, and a is set to 1, so a squared is just 1. And then here you get, this is binomial GIC. Its inputs are 1 and b on a. In this case, a is 1, so b on a is just b. So this is binomial GIC given 1 and b, or 1 and b on a. And then here we get the fundamental circle constant times the quantity binomial GIC 1b plus 4. So this actually ends up looking like this. So the perimeter of your ellipse is very close to the fundamental circle constant times binomial GIC 1b on a plus 4 times a. So this will be for any, a is your semi-major axis, b is your semi-minor axis. For a circle, they're identical and they're the radius. So this will give you the perimeter pretty accurately, and this will give you the area exactly. and that's a really simple equation. Like, once you understand what binomial kick is, this is actually simpler to read than this is, and it's more accurate than this is. And it's way simpler to read than any of these other approximations. This one, Ramanujan's approximations, or like the infinite series, which you can't ever actually finish. They will be more accurate. They'll be arbitrarily accurate, but yeah, that's kind of nice. A nice validation of the concept of binomial kick, of the context-bearing numbers. Just playing with it after like a day, it's like, oh, look at that. We can improve on this substantially. Get something that works fairly nicely and is also really easy to read.